Chapter 6.3 is comparing linear and exponential functions. And the reason I have a picture of an earthquake here is because this is actually the worst earthquake that has been recorded. It was in 1960 in Chile, and it measured between 9.4 and 9.6 on the Richter scale. And the reason I bring that up is because the Richter scale is actually exponential. It actually goes like this. So if you're looking at an earthquake at if it was at a 1, you wouldn't feel it, but let's say you have one that measures 1 to 2. There's only this much of a difference. But if you're looking at the difference between, say, 10 and 9, you're looking at a lot more difference. So this one only goes from here to here. This one goes almost straight up. So that's why I have a picture on here. It's one of those things that we use in everyday life that uses exponential functions. All right, so linear functions can be written as y equals mx plus b. We did a lot of that first semester. Okay, and a linear function looks like a line, thus linear line. Okay, exponential functions are written y equals ab to the x. We covered this in a previous lesson. And they swoop. They can swoop up, they can swoop down, but they tend to get big very, very quickly, or get small very quickly. All right, so using the graph, we're going to plot these points, and then we decide whether or not they're exponential, linear, or neither. So here I have 3, -1, 2, 1, 0, 1, 0, 1, 1, 3, and -1, -1. So here we have a function that looks like this. So is that linear or exponential or neither? Well, in this case, it's neither. I have 2 lines here, but it doesn't go into one straight line. So it's not linear. This is actually something called an absolute value function. Okay, over here we have 0, 1, 2, -2, 4, let's see, 1, 2, 3, 4, -5, 1, 2, 3, 4, 5, -2, 4, and -4, 7. Okay, and if we connect these, we definitely have a line. So this is linear. And finally, I have 0, 2, 1, 1, 2, 1/2, -2, 8, and -1, 4. So this one is coming down like this. So this is exponential. Hope you can see that. Let me get a darker color. Okay. So this actually is just the mathematical way of saying what we've been doing for the last, couple of weeks here. If you have a linear function and you have a table, then it means that each time you're looping to the next one, you're adding by the same amount. Okay? If it's an exponential function, then when we're going from one term to the next, we're multiplying. Okay? And then the x values are constant, so they're separated by 1 or 2, but they're all the same. Okay, so this is what I mean. So we've got -2, -1, 0, 1, 2. So when I said that they're separated by the same thing, they're just by 1, right? This is by 1 every time. And over here too. And that's the case for both exponential and linear. Okay, now here we're going from 9 to 5, and then 5 to 1, 1 to -3, and -3 to -7. And if you look, you can tell that each one of these is being subtracted by 4. Okay, and because it's subtraction, it is linear. And linear deals with subtraction and addition. Okay, Okay, over here, okay, I look and see what's going on, and each one of these is being multiplied by 3. And if it's being multiplied, then it's exponential. And that's if it's being multiplied or divided. Okay, we've seen a lot of these, and we'll still see more. Okay, and that's it. The homework is online, and it was a really short lesson. And let me know if you have any questions.